The universe loves to break its own rules. Every time we think we've figured out how planets are supposed to behave, boom, a cosmic curveball. Today we're diving into 10 real planets that by all logic shouldn't exist. These are the astronomical misfits, gas giants that hug their stars like needy toddlers, icy worlds that orbit the wrong way, and boiling orbs that rain molten glass. These aren't just planets. These are riddles wrapped in atmospheres, inviting us to question everything we know about the cosmos. Number 1, HD 189733b, the glass rain planet. HD 189733b is a gas giant located 64 light-years away, and at first glance it looks eerily familiar. Its deep blue hue gives it an Earth-like appearance, but the similarity ends there. That blue color isn't from oceans, it's from silicate particles in its atmosphere. That's right, it rains glass, sideways, at speeds of over 5,400 miles per hour. This planet is tidally locked, with one side scorched in permanent daylight and the other frozen in eternal night. The atmosphere between these extremes is whipped into a frenzy by violent wind currents. These temperature gradients drive hurricane-force jet streams unlike anything Earth has seen. The planet's temperature can reach up to 1,700 degrees Fahrenheit on the day side, and the winds carry shards of glass from the hot side to the cold. It's a planet sculpted by chaos, with chemical storms and temperature shifts that would tear any probe to shreds. Stunning from afar, hostile up close. Number 2, WASP-12b, the star-eating planet. WASP-12b is so close to its star that it's being stretched into an egg shape by tidal forces. Orbiting in just 1.09 Earth days, the planet is locked in a gravitational death grip. Its star is actively pulling material from WASP-12b's atmosphere, forming a disk of gas that spirals into the star like a slow-motion cosmic sacrifice. Temperatures reach over 4,000 degrees Fahrenheit, and the planet is among the darkest ever discovered, absorbing 94% of all light. Its atmosphere may contain carbon-rich compounds, potentially forming graphite or even diamond rain. It's a planet that's being consumed alive, its atmosphere bleeding into space. Scientists believe it has only a few million years left before it disappears entirely. WASP-12b challenges our understanding of orbital stability. Gas giants shouldn't exist this close to their stars, and yet here it is, a dying world, providing a glimpse into a future that awaits many exoplanets. Number 3, HD 106906b, the banished giant. HD 106906b is a planet that lives in the outskirts of its solar system, and we mean way out. It orbits at a distance of over 730 astronomical units from its star. For reference, Pluto is only about 39 astronomical units from the Sun. This planet is so distant, it takes thousands of years to complete a single orbit. But how did it get there? It's far beyond the region where planets are thought to form. One theory suggests it was formed closer in and flung outward by a massive gravitational encounter, yet somehow remained bound to its star. Another theory posits it might be influenced by a yet undetected companion star or rogue planet. What makes HD 106906b so strange isn't just its distance. It's the fact that it's still there at all. It glows faintly in infrared, suggesting residual heat from its violent formation. It's not just a lonely planet, it's a survivor, cast out but not lost. Number 4, Kepler-78b, the impossible rocky world. Kepler-78b defies all planetary formation models. It's a rocky planet about the size of Earth, but it orbits its star every 8.5 hours. That's closer than any rocky planet should be. Temperatures exceed 4,000 degrees Fahrenheit, turning its surface into a roiling sea of lava. The intense stellar radiation has likely stripped away any atmosphere, leaving a bare, molten world that glows with its own heat. Tidal forces between the planet and star are immense, and the planet is slowly spiraling inward. How did it get there? Scientists aren't sure. It couldn't have formed so close to its star. The environment would have been too hot for rocky materials to clump together, and yet it exists, hanging on in defiance of gravity and heat. Kepler 78b is living proof that the universe often writes its own rules. Number 5. PSRB 1620-26b, the planet from the dawn of time. PSRB 1620-26b, or Methuselah, is one of the oldest planets ever discovered, about 12.7 billion years old. That's nearly triple the age of Earth and almost as old as the universe itself. It orbits a bizarre pair, a white dwarf and a pulsar. These are dead stars, remnants of supernova explosions and gravitational collapse. The fact that a planet exists in such a system is incredible. Pulsars emit powerful radiation and high-energy particles, which should sterilize or destroy nearby planets. Yet Methuselah survives. Not only that, it formed in a globular cluster, an environment low in heavy elements needed for planet formation. Its very existence raises questions about how early in the universe planets could form. It's a relic of the cosmos' earliest days, a survivor of apocalyptic forces. Number 6, GJ1214b, the water world with no surface. GJ1214b is often referred to as a water world, but that term doesn't do it justice. This planet may be composed largely of water, but not in any form we recognize. Its interior likely contains exotic phases of water, including superionic and plasma states, found only under extreme pressures. There's probably no solid surface, just layer upon layer of compressed, hot, chemically active fluid. Its atmosphere is thick and completely opaque. Despite multiple telescope observations, we still don't know exactly what's in there. The pressure at the surface could crush a spacecraft like a tin can. If life exists here, it would be utterly alien, adapted to live in darkness, pressure, and chemical complexity. Number 7. Kelt 9b, the hottest planet ever. Kelt 9b orbits a massive blue star and is so hot it reaches over 7,800 degrees Fahrenheit, hotter than many stars. At these temperatures, molecules can't even stay intact. Hydrogen molecules break into atoms on the day side and recombine on the night side. The planet is being cooked and its atmosphere is boiling off into space. Astronomers have detected vaporized metals, iron, titanium, even magnesium, floating above the surface. It's like a forge in the shape of a planet. Yet somehow, Kelt 9b maintains a consistent structure. It's locked in a delicate balance between thermal expansion and gravitational compression. This planet shouldn't exist, but it shows us what the extreme end of planetary existence looks like. Number 8, WASP-17b, the backwards planet. WASP-17b spins in the opposite direction of its star's rotation. This retrograde orbit suggests a violent past. Perhaps a massive collision or gravitational slingshot sent it spinning the wrong way. To add to the weirdness, it's one of the least dense planets ever found, nearly twice the size of Jupiter, but with less than half the mass. You could theoretically fly through it without noticing. Its atmosphere contains strange compounds, including titanium oxide, a rare chemical that may act like planetary sunscreen, and its bloated size raises questions about how gas giants retain structure in high radiation environments. WASP-17b is a rogue dancer spinning to its own tune. Number 9, TOI 3757b, the fluffiest giant. TOI 3757b is a gas giant so light Its average density is less than that of a marshmallow. It's the puffiest planet we've ever found, about the size of Jupiter, but a quarter the mass. It orbits a red dwarf, which should have blasted it with flares and radiation. Such low-density planets shouldn't survive in those environments. One idea is that its outer atmosphere is made almost entirely of hydrogen, giving it a balloon-like structure. It defies our expectations about gas giant structure and mass retention, and it challenges models of how planets form and survive around red dwarfs, one of the most common types of stars in the universe. Number 10, Gliese 436b, the burning ice planet. Gliese 436b is covered in a strange, high-pressure form of ice, despite being nearly 800 degrees Fahrenheit. How? The planet's gravity is so intense, it compresses water into a solid form called Ice 7, even at extreme heat. This burning ice defies common sense. On Earth, water would boil at a fraction of that temperature. But here, the structure of the ice remains intact due to the crushing internal pressure. Even more strange, the planet's orbit is highly elliptical, causing massive shifts in temperature and tidal stress. And yet, the ice persists. It's a frozen paradox, a reminder that physics has exceptions when you leave Earth. These planets aren't just outliers, they're cosmic riddles, clues that our understanding of the universe is still in its infancy. They break our models, stretch our definitions, and demand new questions. In a universe this vast, the unexpected isn't the exception, it's the rule. So next time you look up at the night sky, remember, reality is stranger than science fiction, and it's still writing itself. Thanks for watching.